Good day, folks. This is the grade 10 and 11 electric circuits without the internal resistance. Let's cut the chase. Now, guys, it's very important to read the statement. It says the following circuit, the 20V, which is volts battery, has a negligible internal resistance. No internal resistance in the battery in the grade 11 and grade 12. Now, guys, the first thing that is important here is to analyze your circuit and follow the current. What is happening to the current? Now, from the battery, there's a total current that moves there in that direction. So it's a total current. And then when it gets there in that resistor there, of course, there's no current that will go in that side, guys. So the current that passes here, it's the total current in that 5 ohm resistor. When it gets here in this junction, there's a split of a current, guys. When there's a split, that means those resistors are parallel. So there will be a split that goes in that direction, and it will be read by that ammeter. And then there will be a portion here that will go straight here, and there will be another portion or fraction that will go through the 6 ohm resistor, and then it combines again and it becomes the total current, right? And then in this resistor R, the unknown resistor, the current that passes here, it's a total current, and then it goes through that ammeter reads the total current. So we conclude that this circuit is made up of the parallel, because we see there's a split in that junction. There are parallel resistors, 3 resistors that are in parallel, and this resistor and this resistor in series, they have the same current. So it's very important to note this. Let's label this resistor. Let's say this is resistor 1, resistor 2, resistor 3, resistor 4, and this will be resistor 5. So guys, the current in resistor 1 is going to be equivalent to the current in resistor 5, and these two, they're in what? In series. It's very important. This is what you need to note. And then the current in resistor 1 plus resistor 2 plus resistor 3, no, not 1. The current here in the parallel section, which is this part, what's happening there? The current in resistor 2 plus the current in resistor 3 plus the current in resistor 4, it's equivalent to resistor 1 and equal to resistor 5, which is the total current. So resistor 1 and resistor 5, they're equivalent, they're total what? Current. Okay, guys, let's go to the questions now. Let's go to the questions. And then we are told here also, before we go to the question, this resistor, out of the 20 ohm resistor, which is supplied by the battery, it takes 20 volts. So the remaining 10 out of 20, it's going to be utilized in this and in this. Remember, guys, the theory is very important, that the resistors in parallel, they have the same voltage. The voltage that is going to be used there is the same, and the resistors in series, the voltage divider, they divide the voltage. So they're going to, all of these, this in this parallel section and this, they're going to take out from 20. Okay, let's answer the question. 1.1, it says calculate the reading of ammeter 1. So the reading of ammeter 1, where's ammeter 1? Is that one. Remember, we said ammeter 1 is the total current. So we're looking for a total current. So how can we find the total current? Guys, first of all, you need to check, do you have the total voltage? Yes. Do you have the total resistance? No, because we have an unknown resistor there, so we can't have the total resistance. So we can't use the method of getting the total current using the total voltage and the total resistance. Now let's find the second option. Which resistor in these resistors that passes the total current and we can find the total current in it. Let's look at the first one, resistor 1. In resistor 1, there's a total current that passes here, and then it goes and splits, and then it combines again, and then it combines again, and then it passes there, and it goes there. So we wanted the total current. So the total current, we will find it here, because here we have the resistance, we have the voltage, so we will have the current, because the current that passes here is the total. Let's do it. So we will say then I is equal to V over R. Using that formula, you find it in the data sheet. So the voltage there is what? Is 10, and the resistance there is what? Is 5. So the answer is going to be what? 2 amperes. Therefore, the total resistance is equal to what? 2 amperes. And the ammeter 1, it reads what? 2 amperes. That's the answer there. Now guys, let's answer 1.2. Okay, let me write it here a little bit down here. 1.2, it says calculate the reading on ammeter 2. Ammeter 2, guys, as you see there, the total current comes there, and then it splits. There's a fraction that goes there, and there's a fraction that goes there, and the fraction that goes there, out of the total current, which is 2. So we wanted the portion that passes here in this resistor. So in order to get the current that passes here, we have to ask ourselves, do we have the voltage there? No. We have the resistance, right? It's 3 ohms. But what we can do first, we will have to find the resistance of this part, right? The voltage here. So once we have the voltage here and use this resistance, we'll get the current that passes there. How are we going to find it? So this is what we're going to do first. Now this is what we're going to do first. We're going to find the current. We're going to find the total resistance of this and get the total voltage of this, because the total voltage of this resistance part is equivalent to the voltage here and the voltage here and the voltage here. So what are we going to do? We're going to first find the voltage here by using the total resistance of this part and get the voltage. Once we get that voltage, we'll be able to get that that current that passes there. So what we're going to do, we will do the total resistance of the parallel section is 1 over Rp divided by 1 over R2 plus 1 over R3 plus 1 over R4. So 1 over R2, it's 1 over 2 plus 1 over R3, it's 1 over 3. 1 over R4, it's 1 over 6. So the answer here, it's going to be 6 over 6. And then it's going to be 1 is to 1. That be 1 is to 1 over Rp. Guys, use the calculator there, and then we invert. It's going to be 1. So the resistors and the total resistance in the parallel section is what? It's 1 ohm. Now we're going to use the parallel section to get the voltage of that parallel section. How are we going to do that? Let's write here the next. So what are we going to do, guys? Since we know that the current that passes, the total current in the parallel section, the current in the parallel section is 2 ohms, even though we know that it splits in 3 parts. So but we know that. So what we will say in one point in the following question, the following steps here, we will say the parallel current there, it's 2 amperes, the total current that passes there, and the resistance in parallel there, it's what? It's 1 ohms. And then we're going to look for the voltage in parallel. So we use the formula that says Vp is equal to Ip times Rp. So it's going to be, what is the current, the total current that passes here? Even though it splits, it's going to be 2, and the resistance there in the parallel section is 1. So the voltage there in the parallel section is what? It's 2 volts. So the voltage that is used here, if you can put the voltmeter, it's what? It's 2 volts. Voltage here, it's what? 2 volts. Even here, if you can put the voltmeter here, the reading, it's what? It's 2 volts. So here, calculating the current that passes there, we have now the voltage there, it's 2, and the resistance. So what are we going to do? We'll say now I in a resistor 2 is equal to V2 over R2. So it's going to be, what is the voltage there? It's 2. Divide by the resistance there. What is the resistance there? It's 3. So 2 divided by 3, it's 0.67 amperes. Therefore, the current that passes here, it's 0.67. Now let's go to the last question. The last question here, it says calculate the resistance of resistor R. Where is resistor R? It's this one. Now what do we know about resistor R there? What do we know about resistor R? What we know about resistor R here, there's a total current that passes here, as I've mentioned. It's what? It's 2 amperes. And the voltage here we do not know. But since we know the voltage total is 20, and this resistor is supplied by this battery with voltage, which is its energy. So we will subtract, we'll say out of 20 we'll subtract this 10 and we'll subtract this 2, and then the remainder will be that, the voltage. And after getting the voltage there, we will get the resistance. So let's do that. We will say V5, which is the voltage in the resistor 5. Remember that one is resistor 5. We'll say out of the total resistance we minus V1, which is this one, it's resistor 1, minus V minus the V parallel minus, okay, I hope you get that, guys. We'll say the V20, the V total, it's 20 minus V1, which is 10, minus the V parallel, it's 2, and then we'll have what? 8. So the voltage here that is used there, it's 8 volts. Right, so we have the voltage now, and we have the current that passes here. The current that passes here in this unknown resistor, we said it's a total current. It's a total current that passes there. So we will say R, which is its R5, equal to V5 divided by total current, which is the current that passes there. It's the total current. The voltage there, it's 8. We divide by what? The total current, which is 2. It's going to be what? 4 ohms. So the unknown resistor here, it's what? It's 4 ohms. That's the answer for that, and that's